Hey guys, in this video we're going to be covering target 2C.3, that is being able to factor quadratics by factoring out the greatest common factor. So the first thing is, well, what is the greatest common factor? It's also represented by GCF, so if I ever ask you to find GCF, I'm talking about greatest common factor. And what that is it is the greatest factor, so this could be a number, it could be a variable, that divides all terms. So it has to be able to be divided by all the terms within our quadratic or expression or whatever we have. So you have to find either whether it's the biggest number that divides them, or if maybe they all have a variable in common. A variable could also be a greatest common factor. So the direction for the next couple is find the GCF of all the set of numbers. So the first one I have here is 1. I have number 25, number 45, and number 65. So some things that also can help us factor out what the greatest common factor of these numbers is our multiplication chart. So if we look at our multiplication chart, I kind of want to find the biggest row that has all these terms. So what I'm going to start doing is I'm going to look at 1, and I look at these numbers until I find those two numbers. So they were number 25, number 45, and number 65. So if I'm looking at this one, I only see a 25, but I need all three numbers to be in that like row. So I don't see a 25 there, I don't see a 25 here, I don't see a 25 here. Once I get to 5, I do see a 25, so let's see if there's a 45. There is, right, 45, because that's 8 times 5, and then there's a 65 as well, which is 13 times 5. So far, 5 is the biggest number that I've seen that can divide all of them. Since these end in 5s, it typically only can be divisible by multiples of 5. So if I look at 10, that is not going to go into 25. 15 doesn't multiply. I see a 45. That's it. So I'm going to say that the GCF, the biggest factor that both 25, 45, and 65 has, is a 5. So our GCF is 5. Again, because we can divide each of those terms by 5 and we get an answer, right? So GCF, greatest common factor that can divide all of these, is 5. Well, what is my GCF with 12, 8, and 16? So a number that can divide all of these evenly. Biggest number. Well, 1, yeah, divide them all. 2, yep, that would be 6, 4, and 8. 3 does not divide 8 or 16. 4 divides all of them, right? 5 does not, 6 does not, 7 does not, and now we're already at 8, but 8 does not divide 12. So the biggest GCF here then would be 4. Right? It can divide all of those, and then is the biggest number. So find the GC, I should say GCF. Not G, and divide it out of each term. So the first thing is, if I look at the GCF, I'm looking only at those coefficients right now, because the other term does not have a y. So if I see a 27 and I see an 18, the biggest number that can divide both of those. And if I see 18, I think of 3 or 9. 9 can divide both of them, and that's the biggest actually number that can divide them. So our GCF for this is a 9. What I want to do then is I want to divide each of these terms then by 9. So 27 divided by 9, and since I'm dividing that out, I'm going to represent that by taking a 9 out, opening up parentheses, and rewriting my new term. So 27 divided by 9 is 3. Don't forget my y. Plus 18 divided by 9 is 2. Now notice, if I were to have distributed that 9 in, we should get the same answer, right? 9 times 3y is 27y, 9 times a positive 2 is a positive 18y. So all we want to do here is we want to be able to take out that GCF, right, which is right in the front here, so that we have smaller terms to work with in our binomial. Right? Well, what happens when we have a trinomial here? And I also see a negative here. So I see a 4, I see an 8, and I see a 2. Now 2 is the smallest number, and the only things that divide 2 are 2 and 1, right? And 2 does divide 4 and 8. So 2 is actually the biggest number that we can take out. And anytime you see that first term as a negative, right, this is a negative 4, try to work with a's squareds, or like first term that's being squared, as a positive number. So what I'm actually going to do is I'm going to say my GCF is a negative 2, so that I can divide all of these by a negative 2 and get rid of that negative 2 as my first term. So again, pull that GCF out by writing that negative 2 in front, and now I'm simply going to divide. A negative 4 divided by a negative 2 is a positive 2. Bring down my a squared. Negative 8 divided by negative 2 is going to be a positive 4a. And a positive 2 divided by a negative 2 is a negative 1. Go ahead and close my parentheses, and I remove my GCF. Alright, next example. I have 15w minus 3. Well, 3 is a smaller number. The only things that divide 3 is 3 and 1. So does 15 can be divided by 3? Yes, it can. So my GCF then is 3. I'm going to divide each of these by 3. So 15 divided by 3 is 5. Don't forget my W. Negative 3 divided by 3 is a negative 1. And then I removed my greatest common factor, so I have 3 times the quantity of 5w minus 1. Next one, I have 3x squared minus 9x plus 6, so the smallest number is 3. So obviously I can't get any bigger than that, but 3 does divide all of those other terms evenly. So my GCF then is 3. So I'm going to remove that 3 out, and I'm going to divide everything by 3. So 3 divided by 3 is 1. So you could put 1x squared. Negative 9 divided by, or negative 9x divided by 3. Well, negative 9 divided by 3 is a negative 3. Bring down my x. That doesn't change. And positive 6 divided by 3 is a positive 2. Now, you don't need that 1 in front of the x squared. So if you had this, that is also acceptable. You don't need that 1 in front, but you can write it if you need it. All right. Now we're going to try factoring by bringing out those GCFs. So if I scroll down a little bit, and so now I'm looking at that first example there, that is 2x squared plus 14x plus 24. I want to find a GCF out of all of them, but obviously 2 is the smallest number, so I want to see if both or all 3 terms can be divided by 2, which they can. Right? 14 and 24 can all be divided by 2. So therefore, my GCF is 2. If I remove that 2 out, that means I'm dividing all of these by 2. So 2 divided by 2 is a 1x squared. 14 divided by 2 is a 7. Don't forget my x. 24 divided by 2 is a positive 12. But now I was asked to factor this. But I have a GCF, and I have a trinomial, which I'm going to use my Punnett square box on. Alright, my x squared term goes in the top left. I kind of ignore that GCF just for the moment. That bottom right term is a positive 12. Now I'm looking for numbers that multiply to 12 but add to a 7. So they're both going to be positive here. And I'm going to be using 3 and 4. Right, 3 times 4 is 12. And 3x plus 4x equals 7x. Alright, this is what we were doing in the last video. So these two are what I am placing inside my Punnett square box, and I'm figuring out the outsides of my square. So x times x is x squared, x times a positive 3 is a positive 3x, x times a positive 4 is a positive 4x, and 3 times 4 is 12. So my binomials, x plus 3 and x plus 4, those are my factors. The one thing I cannot forget is that GCF that I pulled out. So I can't forget to write that big 2 in front of those 2 factors. Alright, looking at number 8, I want to remove a GCF. So the GCF here, well, I look at that smallest number, which is a 3. Can 3 divide the other 2 terms? Yes. Typically the questions that we're going to be working with are GCF. Don't quote me, not always. But most of the time it's whatever is in front. We typically can see that that can divide all the other 2 terms. Alright, so if I divide everything by a 3, that means I'm removing that 3. 3 divided by 3 is a 1. 12 divided by 3 is a positive 4. And negative 15 divided by 3 is a negative 5. So my Punnett square box then, I'm going to have a positive x squared, I'm going to have a negative 5. So I'm looking for a number that multiplies to negative 5. Right, we multiply to negative 5, but then we have to add to a positive 4. So they're going to be opposite signs of each other, and we need a more positive number. So I'm going to have 5 times a negative 1, which is a negative 5, because 5x minus 1x would be a positive 4x, right? Opposite signs because the bigger number has to be positive. So I'm going to have 5x and a minus 1x. That means x times x is x squared, x times a positive 5 is a positive 5x, x times a negative 1 is a negative 1x. And my binomials then are going to be x plus 5 times x minus 1. But again, do not forget that GCF. It makes the problem incorrect because I need to remember that I need to have that GCF. Because I removed it, right? I removed it to make it a little bit easier for me to factor. All right, the next couple of the last two examples here. Number 9. We have 5x squared minus 20. I think there's a typo there. I should have a little x right here. Right? So again, it should be 5x squared minus 20x plus 20. And the GCF here would be 5. Right? I can take a 5 out of all of these terms. So that is exactly what I'm going to do. 5x squared divided by 5 is a 1x squared. Negative 20x divided by 5 is a negative 4x. And 20 divided by 5 is a positive 4. Alright, so I'm going to scroll down just a tad bit and start off with drawing my Punnett square box. So Punnett square. I know I'm going to be multiplying to a 4. And I'm going to add to a negative 4. So we're probably going to be dealing with signs on both negatives. And negative 2 times a negative 2, well, that's a positive 4. And if I were to subtract negative 2x and a negative 2x, that would give me a negative 4x, which is exactly what I need because I'm adding up to a negative 4x as that middle term. So my x squared, that positive 4, these two terms are what I'm placing in the empty spaces. And then I figure out what is on the outside, right? So x times x is x squared, x times a negative 2 is a negative 2x, x times a negative 2 is a negative 2x, and negative 2 times negative 2 is a positive 4. Right, so those are my two binomials, but again, don't forget to bring that GCF down, which is a 2. One side note, if I see that these two binomials are exactly the same, you could also rewrite this as my GCF of x minus 2. If I'm multiplying those two things, I could also just square it. Because I see that those two binomials are exactly the same. If you forget about that, that's okay. But it's one thing to keep in mind. Our last example here, I have a 4x squared plus a 20x minus 56. And our GCF here is a 4. So I'm going to divide everything by 4. That's going to give me 4 parentheses. 4 divided by 4 is a 1x squared. 20 divided by 4 is a positive 5x. And negative 56 divided by 4 is a negative 14. Again, use your multiplication chart, use your calculators, whatever you have to do. I'm going to draw my line here so I don't get confused. My Punnett square box then. I'm going to place in my x squared. I'm going to place in my negative 14, which I know I'm going to be multiplying to. And then I have to add to 5. So if I'm multiplying to a negative, but I'm adding to a positive, that means I need I need opposite signs. And the bigger number has to be positive. So 7 times a negative 2 is a negative 14. And if I were to add these two together, positive 7 and a negative 2 is a positive 5x. These are my two terms I am plugging into my Punnett square box. Figuring out the outside. X times x is x squared. X times a positive 7. X times a negative 2. So my final answer then is x plus 7 times x minus 2. Again, don't forget that GCF that I did bring out, so I need a big 4 in first. Alright, go ahead and work on activity 2C.3. Good luck.